Hello student, let's try to understand crystal field theory student. Crystal field theory. What are the postulates student? Crystal field theory assumes that bond between the ligand and central metal atom is purely ionic student. The bond is formed due to electrostatic attraction between the electron rich ligands and electron deficient metal student. Second point, in the coordination compound, the central metal atom, ion, and the ligands are considered as point charge, electric dipole student. According to crystal field theory, the complex formation is considered as the following series hypothetical space. So that is what the major point is. What student they are considered to be what student purely ionic bond. It is considering the purely ionic bond, and that is both are considered to be what student central metal atom, and the ligands are the point charge student. Now the second step you see student, the ligands are approaching the metal atom in octahedral bond directions. Considered an octahedral field in which the central metal ion is located at the origin of the six ligand are coming from the plus x, plus y minus y, plus z and minus z direction. The orbitals lying along the axis, that is dx square minus y square dz square, will experience the stronger repulsion and rise its energy to a greater extent than the orbital with lobes directed between the axis dxy dyz dzx. Thus, the degenerate d orbital now split into two sets, and the process is called crystal field splitting. So what is happening here student, suppose 5 orbital are there, okay, d orbital, and when ligand is approaching it is splitting into two set student. Two set means what, the orbital which are present along the axis will face the more repulsion, so it will be the eg set to have high energy and t2g set low energy. So this is the octahedral splitting energy student. Now come for the next one student, in case of the tetrahedral complex. Up to this point, the complex formation would not favored. However, when the ligand approaches further, there will be attraction between the negatively charged electron and the positively charged metal ion that result in decrease in energy. This decrease in energy is the driving force for the complex formation. So, dear student, first of all, when the ligands are there, octahedral complex, ligands are approaching from the axis student, okay, plus x minus x. So, firstly, when the ligands are there student, without ligand, this is the degenerate orbital student, degenerate orbital. When the ligand approaches student, so average energy increases student, average energy increases, d orbital average energy increases, and finally this d orbital will split into two set student. What is this set is called student, this is called t2g and eg set student, this is called t2g set and this is called eg set student. And what is the difference student, here you see the difference between these two student energy, that is called delta naught student. De, naught means the delta O, you can say student, octahedral splitting energy student. What are these orbital student, dx square minus y square, and this is the what student, dz square, because the lobes are along the axis student, so they face the more repulsion and so the energy will be high student. This is dxy student, dyz student and dzx student. So this is what is the crystal field splitting in a student in the octahedral complexes. Thank you very much for watching students.